Hey everyone, welcome back to the channel. Today we're diving into the world of Rust programming, and I'm going to show you how to write and understand a recursive binary search function. If you're new here, don't forget to hit the subscribe button and the notification bell so you don't miss any of my future videos. All right, let's get started. So today we will be writing our binary search recursive function, and we're going to break it down step by step so you can understand exactly how it works and why we use certain features of Rust, like the option type, right? So let's jump back into the code. So first things first is let's import our ordering enum from the standard library so we can compare values. And to do this, let's write use std : cmp : ordering. And this will help us compare those values, right? So next, we will define our function, and our function will be called binary search recursion. And it's a generic function that works with any type T that can be ordered. And this looks something like this. And to do that, we can write pub, public function, binary search recursion. Let's say T of type T or D. And let's give it 4 parameters. Those 4 parameters are a list of items and a reference to an array of T, our target value, and this is reference to T, then our left pointer, which is a reference to usize, and then our right pointer, which is again the same thing, reference to usize. Next, let's return our option enum. This is to make sure that our returning value can be none or our found value. Awesome. So let's make sure everything looks good here. So, right, we have our 4 parameters, list of items, the target item to search for right here, a reference to the left and right boundaries. So left, right, and it returns an option of usize, which means it will either return some index or none if there isn't anything. And that looks good. So next thing to do in our recursive formula or our recursive method is to write our base case, right? So we could do this by saying if our left pointer value is greater than or equal to our right, we're going to return none. So if the left index is greater than or equal to the right index, it means the search range is invalid. So we return none, indicating that the target is not found. Next, we need to check if the list is sorted in ascending order. We can do this by saying let is ascending or let is C for is ascending. And then we grab our list of items and then grab the beginning value or 0 and then go to the end of our list of items or grab the length of our list of items -1 and then compare it. So this means that we compare the first and last element of the list, first and last element of the list, and if the first element is less than the list is sorted in ascending order. Okay, great. So next thing to do is calculate the middle index of our current search range. To do that, we could say let middle type usize equals left plus right minus left minus or divided by 2. This formula ensures we find the midpoint without risking overflow, which is especially important for large lists. All right, so next thing to do is check if our list is sorted. We compare the target with the middle element. And to do that, we could say if ascending, let's do a match on our target and then compare it to our reference to our list of items at position middle and check if it's less than. Check if it's less than. And that looks like this. And if it is less than, we want to call our binary search recursive method and then pass in our list of items, our target, the left value, and a reference to the middle value. If our ordering is greater than, we want to call our binary search method again. But this time we want to pass in our middle point plus 1, as well as our right over here. And then if the ordering is equal, we want to return just the middle point. Awesome. So what happens if our array is not ascending, right? Essentially, if that happens, we will want to do the inverse of what we just did. So let's take our match up here and then just invert our functions here. So instead of when greater, we check the right-hand side. We want to check the left-hand side and vice versa. Awesome. So this looks good. And essentially what's happening is here, if the target is less than the middle element, we search the right half. And if it's greater than, we search the left half. Again, if it's equal, we found our target. Awesome. And just to make everything work or make sure everything works here, let's go ahead and run some tests. So we could run that by saying cargo test. But first, let's actually import our file inside of our main function so cargo knows where to look, right? It's very important. And everything looks good here. But let's kind of encapsulate this. Parentheses, because our compiler is complaining. All right, everything looks good here. So let's run our tests, see what happens. As you can see, as usual, we write all our tests out in the beginning. And again, it's always on our blog. So if you want to take a look, it's up there. Let's run our tests, and great. All 11 tests are passed, meaning that our recursive function works. And that's it. So we've successfully broken down and understood the recursive binary search function in Rust. If you have any questions or suggestions for future videos, leave a comment below. If you found this video helpful, give it a thumbs up and share it with your friends. Thanks for watching, and I'll see you in the next video. Happy coding.